wanted to create wireless energy, so I've been looking into the work of Nikola Tesla. I wanted to know exactly what it took to start a Tesla coil and then to get another one to ring without any other attachments, basically just the number 2 coil by itself. It took a lot of work to get there, and hopefully through this whole video I can show you every step in the process on exactly how I got it done. The driving circuit we're going to use for our Tesla coils is a ZVS board. We're going to remove the original capacitors. We're going to put in a high frequency set of capacitors. The capacitors themselves are bipolar, so it will not matter which direction that you would like to place them in. Just make sure that each connection is secure, make sure they're soldered in place, and make sure you put insulation around them. Now that we have our ZVS modified, it's time to start connecting it to our Tesla coil. We're going to start with the power itself. On our negative, we are going to put a switch. On our positive, we're going to run it straight to the ZVS. When you're done screwing everything in, it should look exactly like this. There are 3 more wires that need to be connected in order for this circuit to be complete. On your right is going to be the base of the Tesla coil. On the left, it is going to be where you're going to set your oscillation frequency. The last one that gets connected in is the number 2 coil itself on the bottom has to be connected to a ground cable. With the driving circuit now complete, it's time to move on to building the Tesla coil. I used Fusion 360 in order to build the base of my Tesla coil. It's important to make sure that each coil winding is exactly the same distance from each other. This helps when you go to put it into oscillation. Leaving room for a ground cable to connect to your number 2 coil is also important. I also put in an inner ring. This way my Tesla coil sits exactly where I want it to at all times, the correct distance from the number 1 coil. The receiving coils do not require a number 1 winding. Therefore, we're just going to build a simple base for each one. In order to build the number 2 coils for this project, I started out with a piece of 4-inch PVC pipe. I then cut each one to 12 inches in length. I sanded each one to remove all of the ink. Once all of the ink was removed, I took isopropyl alcohol and wiped each one down. The windings themselves are made out of 32 gauge magnet wire. The frequency we were looking for in the coil was 361 kilohertz. When I finished winding each one of the Tesla coils, each one was exactly the same. 5 Tesla coils matching the exact same frequency. All we had to do now was wait for the 3D printer to finish printing out all the bases, and we were good to start testing. As you can see, the STL turned out perfect. Those windings look beautiful. We have it clipped on over here. And as you can see, I ran it out the bottom like this, and the top one has to come off a little bit just because they like to spark over, but I capped it. So that's really good. I'm going to run it right now at 11.3 volts, and we're just going to go ahead and turn it on. And then we're going to check to see on our oscilloscope if we're resonating. So we are on. 253, 52 is what it's resonating at. I want you to watch this. I'm going to scale this. That's beautiful scaling right there. So that right there is simply at 18 volts. As you can see, perfect. Exactly what we're looking for. Lights up beautifully. I got these covers, man. They're so awesome. Got different colors of them. Can't really see them unless it's at night. So let's go ahead and do this. We're going to look just real quick. We do have a tiny bit of breakout right there. Not much. let's turn off the lights and let's see what this thing can do. You can see that red light up. That just looks sinister, doesn't it? Look at that. Vroom, 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 vroom. That's just awesome. Okay, try a different one. We got a blue one. Man, it's bright. Look, it goes at a distance. This is a great Tesla coil right here. Perfect, exact way to make it. That's just cool. Okay, let's try some other colors real quick. There's a pink one right there. It's amazing. So you say, well, Nathan, I thought this was supposed to be a Tesla coil that lights up. Well, watch this. I'm going to hit this thing with black light. Look at that. That black light just charges it up real fast. That's absolutely awesome. This is yellow. They kind of bright up white in the camera, but man, when you're here in person, they come out perfect colors. This is my green one. Oh yeah, you can see the green hue everywhere. Looks so cool next to that light in the dark stuff. All right, hold on. This one is orange. Oh yeah. Look at that. I love the glow in the dark. And you can see the little bit of a breakout I'm getting. Not very much, but that's awesome looking. I mean, I can go crazy with all kind of STLs I could build for this thing. And like I said, it goes down a little bit. Take your black light, shine it over it. Just like that, charges right back up. That's my black light right there. Look at that. That's so cool. Sorry, man, I love the colors. I just absolutely love them. As good as all of this looked, I knew I had a problem. I had set every coil to resonate at 361 kilohertz. I was getting 252 kilohertz. But we'll continue. This coil right here and this coil down here are wrapped exactly the same. As long as this one resonates properly, this one turns on. It's only going to a ground only. There is no other windings connected. You see there's not even a number 1 coil to it. What I'm finding is if it resonates this one properly, that one should turn on. Right here turns on. Nice and bright. Off. Back on. It's a weak resonance, but it's still resonating. Interesting. And like I said, here we are right in the middle. We have no power whatsoever. Right there, it turns back on. So I'm going to set this down. I'm going to turn off the light, and we're going to take a look at it one more time, and then we'll turn it back on. And I'll show you what's going on. And then we'll go over here. It looks dark. There it is. It's lighting it up. I don't think I'm in perfect resonance yet. I think I'm in sympathetic resonance right now. I'm going to have to adjust this a little bit more. And I'm not sure exactly which way to go with it just yet. But I can show you that light definitely turns off. Then we can see the field. We can pull it. And it doesn't make it to the other Tesla coil. But then I go over the Tesla coil and it lights up. So we're definitely in sympathetic resonance. I don't think I hit full resonance yet. But that's probably a better light right there to see it. I was so excited to see when I put the ground wire to it that the resonance started to happen. We started to get some distance, but it's still not what I was looking for. You see, my coils were out of balance. I built every single coil the exact same. That was a mistake on my part. I did not realize that the primary and secondary of the original coil, the primary coil, is going to be different once it oscillates. You see, it lost 100 kilohertz. So every coil thereafter was out of the frequency. I had to rewind that original coil. Once I did, things started to fall in place. I am forcing this coil to resonate right now. And what do I mean by that? Well, here's the number right here. I need to hit 361 or right close to it, 362, 363. When you take this coil right here, it doesn't naturally resonate at that frequency. So I'm forcing it in by changing the capacitance in order to do it. But what if I just ran this thing at natural frequency? You see, the other coils won't pick up at all when I put it in the natural resonance. But the amount of power I'll get will jump. So I'm not going to touch this oscilloscope at all. All I'm going to do is change the resonance through the capacitors. Just watch. It's going to jump off the scale when I hit true resonance. Look at that right there. Now, I got a lot more power out of that, right? And right now, a very, very small breakout going on because we are at 11.7 volts. So those all turned on at that voltage, but my frequency sucked. So what am I trying to show you here? This coil here needs to be redone. It is resonating. Sorry. 255 right there. Why is that? You see, not a lot of people talk about this because I don't know if they understand it correctly. When you put two coils in resonance, the number one and the number two coil, what starts to happen? The frequency will drop. Now, each one of these coils, keep in mind, they're all built exactly the same. 361 is what this should resonate at, but it doesn't. It resonates in the 255. So as I build this coil next time, I have to keep that in mind. I am literally going to drop 100 kilohertz when I put it in resonance. Now, there's a math calculation that everybody should learn. This is not what you think it is. You see, if I drop this right here and put it in the correct frequency the first time without manipulating it, I get this. You see, I need the resonance itself to amplify just like that. I am so far out of resonance on this, it destroys putting this at distance. So the understanding is this: I could take out those two center coils if I put it in the correct resonance. Right now it's not, and I'm forcing it in there. If I want distance, that coil must match the resonance frequency of this, not the actual coil itself, but what it makes in resonance. So if I were to do this project again, you build this coil, you build each one of these coils to resonate at the frequency this one resonates at. So I hope everybody understands the difference here. It's not so much the power you put in. I think everybody gets the misunderstanding. We're not building a field like this. That's not what we're doing. We're taking this and we're simply ringing it like a bell. And as we're ringing this bell, these other bells should turn on. Anyway, I just wanted to show you that when you get things in true resonance, the power level goes down, by the way. It doesn't like the high power. It likes to be at very low power when it's in resonance. Then everything else starts to work properly. I'm resonating right now at 253, and I am at 17.8 volts going in. That gives me almost 3 and probably 3.5 amps. Okay, so this is what's going on. None of these things are lit up. I have my little light over there. It's just shining over here to see what we're doing. None of these coils are set up to anything. All their wires are hanging. We have zero of anything connected to them. They're just sitting there as coils. So watch what happens. We'll turn this light so that these things shine. You can see them turn on. When I touch them on the tops of these, lights will start to turn on. Now, it's kind of a weird effect. I understand. It's my body is capacitance in this case. And it just means that I'm out of tune on my Tesla coil. I know that I'm 100 kilohertz out of resonance. I left this part in the video so that you guys can understand capacitance. You see, anytime you connect a capacitor to the end of your Tesla coil to pull energy out, it's going to add capacitance to the number 2 coil itself, just like your body does. Now, you know to calculate for it. These are my Tesla coils resonating. As you can see, the lights here are turned on. That's not the impressive part about this. You see, this Tesla coil is the only one plugged into anything. These are simply just receiving coils. No ground, no power, nothing. They're simply just wire wound on a simple pipe, and they're taking in the frequency of the primary coil here in order to resonate each one of these to turn on the light bulb. Now, I'm going to turn on the lights, and I'm going to show you that they are attached to absolutely nothing. We're going to walk around right here. I am at 13.9 volts. My coils are resonating right around 361 kilohertz. Now this coil generally runs in about 250 kilohertz. Here's the trick. We took the ZVS board here. We added Ian's switching board. He said it's a Master Evo design, so credit to both. Ian, thank you for building this. But I just wanted to show you by changing this, I changed the resonance of this. As we saw by this right here, I'm not even at half the power I could be. But at 13 volts, I'm lighting up light bulbs. So let's just check this out a little better. So I literally have the wire right there. And the wire right there. This isn't a game or a trick or anything. It's resonance. It lights it up when it goes next to it. It's amazing to see resonance turn on so many Tesla coils. In fact, it's amazing to find out that the number 2 coil is the only thing that's there. It's connected to nothing. Yet, it rings and continues to make the next one and next one after it do the same. So, in a way, we created wireless towers. However, I think there's more energy in there we could do better. Let's fine-tune our resonance and bring this thing together and see if we can't get a plasma breakout from it. I built a new number 2 coil for my primary driving circuit. Now, things are starting to work better. It's now resonating at 340 kilohertz. I had to put a rod down the center over here to change the frequency of this coil, but I got it all the way across the table now. So I'm still 20 kilohertz out of sync with this in order to get it right. And this right here, by the way, is the biggest hindrance. You see that breakout? You see, I'm at 11 volts. Problem with the ZVS is I can't get it under this. So I may have to switch to Slayer Exciter because I can get down to 10, but I can't get it further than that. And that right there, that breakout kills your resonance. So I'm across the table now. That's a plus. I'll have to chop down the rod. I'll have to redo the math on the coil and make one more. But we're almost there. And I know that sucks to hear, but man, I really wanted to put this thing in right. The crazier thing is, like I said, the lower the voltage, the better it is for the resonance because you don't have the breakout. The rod down the center of the Tesla coil is dropping the frequency of that coil by 20 kilohertz. And instead of rebuilding that coil again, I did what everybody hates to do. I simply pulled windings off of it. Every painstaking hour it took to put those things in, I had to pull some off now. Then I finally got it in resonance. I have my original Tesla coil running. I now have plasma discharge here, down there, over on this one. Oh man. That means I'm putting out a mass dose of energy there. Look at that. Oh my God, that's bright. Oh wow. Oh yeah, baby. That's the way it's done. That's so cool. It's picking up the energy and driving it right through that coil. No better way to see it than that. I know the plasma discharges are small, but so is the original one. So let me get around here so I can show you guys what 12 volts. Look at that. 355 to 358, somewhere in there. It keeps going up and down a little bit. But man, it's resonating really well. Look at that. That is so cool. I removed several more windings for my number 2 Tesla coil, my primary driver. Now, it put it in perfect resonance with the other coils at 361 kilohertz. The result? I got swirling plasma. Now that I've done all the testing, to see it work is absolutely amazing. 5 feet of distance with absolutely zero connection to anything else, just a number 2 coil. That's absolutely amazing. When I started this, I didn't think I was going to get that much success. And then a bonus on top of it. We actually got swirling breakout on a number 2 coil without any primary coil attached to it at all. That's absolutely amazing. I love the fact that everything started to work, but we had to learn a lot about resonance in order to get me there. It took starting it out, building it the wrong way, finding the mistake, rebuilding the primary coil, then working through each step. Did it need to be grounded? Does it need something else? Now, I guess the only question is this. Is this exactly what he was trying to give the whole world? Well, I guess that's up to you to decide. Thank you very much for watching, and have yourself a great day.